In this video, we're going to be looking at or making a function on the TI-nspire, which will do inverse hypergeometrics. Now, before we do this, we want to make sure that this has the hypergeometric CDF programmed in, and notice I do have that here. So the way I've got mine set up is I've got a document called statistics, and in that I have these functions, and these are the ones that I've programmed in earlier: a hypergeometric PDF and CDF, and then inverse geometric and inverse binomial, and we're going to add to that an inverse hypergeometric in this particular one. So our first guess for A is given by this formula down here. And so we need to put this in here. So let's do that first. We're going to store that as A. All right, so we're going to go to Menu. We're going to go to Probability, Distributions, and we want inverse normal, which is this. The area means the probability to the left, the cumulative probability. Should be called should be called cumulative probability rather than area probably, but it can be represented by area. The mean is this mn over this. Now, by the way, I've got two n's here, so I'm going to use T for the capital N and N for the N because it doesn't like 2. And it also doesn't like it to put nm that thinks is a different variable than n times m. So we want to be sure we can do this. So this is n. To be sure we put the times in, m. Okay, and it's not case sensitive. So I'm going to divide by a different variable. We're going to use t instead of capital N. Now the standard deviation is a square root of, all right, this is kind of complicated, so let's see. We want to put in parentheses. Okay, that's a t instead of a capital N, minus a little n, close parentheses, a lot of attention to detail here. Divide by open parentheses, capital N, that's t, minus 1. Okay, that's going to be times n times p, which is m, divided by the total in the population, which is t, times parentheses 1 minus p, which is m, 1 minus q, which is q, which is 1 minus p, m, and then divide by n. No, that's not n. That's t. That's the total. Okay, I think that's right. So we close out that fraction, that one, and close out the square root. I think that's what we want. Let's hit enter. And we want to take all of that and we want to store it as A. So that's our first estimate of A. Now what I want to do with this is I want to go here and I want to go to number, and I want to go to number tools and go to integer part. I want to do the integer part of A, and that'll drop the decimals off, and I want to go down by 1 from that. So this is definitely going to round down. But I don't want it to go down too far. It can't go below 0. So I want to do the max of 0 and this number. Whichever one of those is bigger, and I want to store that as A. Okay, so that's my first A. All right, so change this around a little bit, but that's basically the formula that we have for our A. Now we want to take that A, one bigger and two bigger than that A, find the CDFs of those, and also use those as my 3x's, find the CDFs of those 3x's. But then we also want to find the proportions there, and we want to make a matrix. So we're going to have 3 columns. We're going to have 3 rows for the data, and then a 4th one for a label. So let's do this. So we want to make a matrix. Okay, so now what? Now we need to start setting up our matrix. Okay, so watch what I put in here. We're going to put in a thing for our matrix, and this is going to be for our first row. This is going to be labels, so it's just going to be x, comma, and let's do proportion. You can use these proportion, P-R-O, etc. P-R-P. Proportion. And then do CDF of x there, and that's our labels. And then another set of brackets will go to our second row. Our second row will be A, that A value that we have above. It'll be the proportion of A in the sample. So that's going to be A divided by N. And then we will have the CDF, and that is from here. That's the hypergeometric CDF that we hope we've got programmed in. You got to have that programmed in first. And the inputs to that are the total. So total, and then we want the M, N, and then we want 0 up to A. Okay. And then I'm going to copy that, Control C, and then go here. That'll be my second row. Control V for my third row, and it's going to be the same thing except this is going to be A plus 1. This will be, I need a parentheses, A plus 1, close parentheses, and keep going over. And this guy is, I don't need parentheses, A plus 1 there. Copy that. And stick it in here, paste it, Control C, copy, Control V, paste, just like in Windows. And then a 2 here, 2, 1 becomes a 2, there. All right, now that's what we're going to be our matrix, and we want to store that in the function, which we're going to name inverse HGO. Now we're going to have to pass that the parameters, the total, number in the population, the number of successes in the population, which is P, the sample size, which is N, and then we want to pass it cumulative probability C. And this should generate a new function, which is given there. And that's what it looks kind of like there. Okay, so hopefully we've got this thing in like we need it to be, hopefully without any errors. Let's check it out now. So now I can use this by going to here, doing an inverse hypergeometric. So say we have a population size of 200. We have, in that we have 50 successes, and we want to draw a sample of size 20. And we want to find at what point do we reach a cumulative probability of 0.9. Something it didn't like. Okay, let me see if I can figure this out. Okay, let's try this. Let's see if this will fix it. Highlight this expression here. Without the store. Let's see what. Okay, that comes with a variable expression. That should be good. Now take that and say take that answer and store it in the function inverse HGO total MNC. Okay, this may have fixed it. Okay, so now let's go here and inverse HGO. Let's try it again. Sample size or population size of 200, 50 successes, sample size of 20, and we want to see when the probability first gets to 0.9. Let's see if this works. Yep, perfect. Just what we wanted. Okay, yeah, looks good. So we have our labels, x, proportion, and CDF of x. We have our x values of 6, 7, and 8. We have the corresponding proportions of 30%, 35%, and 40%, and the corresponding CDFs over here. And notice it first reaches above 90% right here at 7. 8's going to be well over that. 6 is not going to be quite there. So if we're looking when the first time it actually reaches that, we're looking at 7. It's actually almost 91% there at 7 for cumulative probability. But this would be the 90th percentile, or really almost the 91st percentile as well. If we want to find the median of the same distribution, we can put in the same numbers, but the median is when this is 0.5 for the cumulative probability, and that first reaches 0.5 at 5, so 5 is the median. Similarly, you could do the 25th percentile or whatever. Okay, so there it is in the calculator.